Thank you, President Dow. Thank you, Mari, and thank you, Superintendent, for this opportunity to speak this afternoon. First, can I be heard well in the back? Yes. As you heard, grant programs and peer review of their proposals. These two principles were both entirely new. They were transformative and they were profoundly influential. Previously, funds for research were doled out in very small amounts by universities and always to the most senior scientists, which hindered the development of young scientists and especially preventing the decay before the current American administration added a crushing blow of not only ignorance of science, but also antagonism toward science. With that gloomy introduction, I'd like to turn to something joyful, and that is the science that we support. And it is, of course, a superb and wonderful scientific audience associated with concerns of a different kind that we can speak about in the discussion that are also real concerns. The second story will come from my own Stanford University laboratory. Both stories pertain to the so-called central dogma of biology, which is, I'm sure, well known to all of you, that it's a starting point for both of the stories that I'm telling you. Now, this, of course, relates to both the replication of DNA and thus heredity, but especially, and what I will have to speak with you about today, the first story I'll tell you relates to a therapeutic intervention at the level of RNA, and the second concerns the very first step. The first step proved to be the most unfortunate prognostication, and we're still in trouble everywhere in the world today. The end of disease, which, with a question mark, which I entitled this lecture, is probably more likely to achieve a successful conclusion, and I'll comment further in a moment. But to continue, as I say, I'll speak in the first of these two scientific stories about an intervention in the process of gene expression at the level of RNA, and especially as an example that relates to future pandemic preparedness, but as I'll tell you, the application is far broader. And it relates in the case of the problem of the danger of pandemic disease to not only SARS-CoV-2, which and the whole family of coronavirus is well known to you, but even more so, influenza, more likely to be the source of the next global pandemic. This slide simply illustrates that in all of pharmacy, which is suppository for hepatitis C virus, that level of reduction in viral vaccine, whereas a solid interfering RNA directed against a conserved region of one drug against influenza, Tamiflu. A former student, now a faculty member of our department in Rio, and then longtime collaborators, Maya Ezubel and Donald Chen. The problem is posed by the picture that is shown in the next slide, and it's one that is familiar to many of you. And a picture like this, a light microscope picture of a cell during most of the cell cycle at the top, and then a cell in the process of division at the bottom. Familiar, I'm sure, to almost everyone in this audience. Pictures like this taken through light microscopes for well over 100 years show, as I said, decondensed for the purpose of gene expression during the majority. 20 years after my proposal of the nucleosome idea, this atomic structure of the nucleosome red and blue in these amino acid sequences of the elastic and the ion, in our case actually, total collapse to an essentially solid state. It will undergo phase transitions. What that refers to is the aggregation of low complexity proteins, the locations of 520.
The stage and lead the Q&A session.
So I'm happy to take any questions.
Thank you, Professor Kornberg, a very informative talk. I'm Joe Wu from the National Defense Medical University. And I just was ask you a question that the slide you raised about the strategy to end of the disease and so many choices. And I just want to ask about that. Have you ever heard about specialized problem-solving mediated from Harvard Program Women Hospital, Charles Sartain? Because I knew the kind of SPM can do like from the solution of inflammation and to tissue regeneration. I also participate in the project as well. Dental disease, and so I was wondering if I can hear about your opinion about this.
So the methodology you're referring to, please repeat that?
It's kind of limited. It's a specialized mediate.
Actually, most, if not all, disease, including infectious disease, including degenerative disorders, including, if you will, aging. May finally be under our control. So, absolutely, I didn't mean to.
Is it possible that the small interference RNA cannot is blocked by the brain, and if that.
Yes, absolutely. So, I gave the example of naturally occurring polyamines, methylene, spermine. Beyond what you've just said, I think the evidence you've mentioned and that of others actually points to such a possibility. We do know that targeting acceleration, targeting reacceleration along the lines can achieve this effect. What really lacking at the moment is to find what are the masters these processes and how they occur in a processive manner across a relevant region. That's still a mystery.
And follow their instructions.
Okay, 1, 2, 3. Come up. 1, 2, 3. Okay.
Thank you all for participating in today's lecture. Let us once again express our gratitude to Dr. Kornberg for visiting Academia Sinica and delivering an excellent lecture today. Please give him a big round of applause. We will be hosting 9 more keynote speaker sessions in Academia Sinica for the Taiwan Regis Lecture Series. Our next speaker will be Ms. Pawar, the 2018 Nobel Peace Laureate in Human Rights